Hello everybody, today we're going to talk about how to evaluate this equation. As we see that there's a ln x in the denominator of the fraction, so this integral calculation may be a little bit hard and tricky. So we're going to talk about the two ways we solve this equation. The first one is double integral. The second one is Feynman integral. So now we talk about the double integral. The double integral, as we know, is use the double integral calculation. So how can we create this situation? So first, we rewrite this equation as x power 1 over ln x minus x power 0. Ln x times dx, right? So let's look at the equation. Can this equation be rewritten as the function fa, the function f1 minus f0? Because we see the two fraction. This is a difference of the two fraction, right? And the only difference of the two fraction is the power. So we can set a function fa equals x power a over ln x, as our goal is to remove this ln x out of the equation. So if we find the differentiation of fa, it will be x power a. Why? Because the differentiation of x power a is ln x times x power a. In this way, we treat x as a coefficient. So as a constant, right? As a constant. So this function's differentiation will be ln x times x power a over ln x. And the answer is x power a. These two differentiation is both treated as constant, because these two function is with the respect of a, right? So it's gonna be x power a. And now we're gonna move on. Because we need to find the antiderivative of this equation. So this could be a integral from 0 to 1, the differentiation of fa with respect to a, dA, with respect to a, m times dx. All right. In this way, we remove ln x out of the equation. So our goals are achieved. But what we're gonna do next is to exchange the evaluate order of the equation. And as we know, the derivative of function a is x power of a. So x power of a dx dA. We're gonna evaluate this equation first. So this is what? This is 1 over a plus 1 times x power of a plus 1 from 0 to 1. So this is what? This is a plus 1 times dA with 0 to 1. Oh, or I can give you some seconds to think what happened. Because this equation is with respect to x, so the a would not be affected, right? So put 1 in the equation, put x equation, and we find the value of the difference. So we find 1 over a plus 1. Lastly, this a plus 1, ln a plus 1 from 0 to 1 is ln 2 minus ln 1. Ln 1 is 0, so the final answer is ln 2. And we're gonna talk about the Feynman integral. I think these two ideas is a bit similar. The idea is a bit similar, but you're gonna see it. Now here is a Feynman integral trick. We're gonna evaluate this equation, and we create a function IA equals the integral calculation a x power of a minus 1 over ln x dx. When a equals 1, it's the equation what we found, x minus 1 over ln x dx. So this is the thing we found, right? And now we differentiate the IA equation. So how can we find the differentiation of the function? Is we should differentiation the inner equation of the big equation. So as we've been mentioned before, this one's derivative is ln what? It's ln x times x power a. So this equation is with respect of a. So if we add a ln x in the denominator, the outcome would be x power a. That's very clear. So the differentiation of the I equation is x power a dx, right? So it's a plus 1 over a plus 1. So we have been known that the differentiation of I function is 1 over a plus 1. So we could actually find the original I function is what? Is obviously is ln ln x plus 1, right? So when a equals 1, we should what we want to find is when a equals 1, the equation is y, right? So when a equals 1, The I one is ln 1 plus 1 is ln 2. Oh, we find the final answer, right? This ln 2 is equals this ln 2. So this is the idea of the Feynman integral trick. It is quite directly and it's brief, right? This subtle equation. So that's what we talked about this day. Just the other thing we're going to talk about this day. Hope you enjoy it.